probability you've seen probably back in seventh grade is probably when you were introduced to it. But we're going to look at this a little bit differently and apply some geometric pieces to it. But first, we're just going to look at the very basic introductory piece of probability with theoretical probability. So, theoretical probability is just calculating the likelihood that something is going to happen. So if something is for sure going to happen, then the probability is always one. So, if you want to think about some things that, are for sure going to happen, then that probability would be one. And then the probability of something that cannot happen at all, then that probability is going to be zero. So, the probability that I will see a shooting star whenever it's sunny outside is probably zero, because you just can't see it. So even if there was something, I wouldn't be able to see it. So something that just absolutely cannot happen is that probability is going to be zero. So we use a certain notation. We use the P and then open parentheses of A. That means the probability that A, whatever that the event, that's what we call the event is going to happen is A. So that's the desired outcome. So however many A's are in your total outcomes, then that's going to be your numerator. Then your denominator is all of the outcomes. So all possible outcomes. And so that's going to be the denominator. So if you have a multiple choice test, then you have four possible answers and you have one right one. So the desired outcome is the right one. And then the total possible ones are four answer choices. So your desired is one, and then your total is four. And then something that is not A, so everything that is not part of your event, you can take everything that's going to happen, or that's going to happen, which is a one, that probability, minus the outcome, that probability of A. So this piece right here that's going to be considered the probability of A, because that's this piece right there. So if it says not something, then you can take one minus the probability that it would happen. So if you have, again, one desired outcome. So the probability that you don't get an answer correct is going to be one minus one fourth, which would be three fourths. With the desired outcome of a wrong answer would be three divided by total outcomes, which would be four. So you could do it either way. So you can either count them up if it's countable, or you can use one minus that probability. Let's take a look here. So we have a bag of marbles that has five red, three green, and one yellow, and we're going to find the probabilities. So we're looking for that desired outcome divided by the total outcome. So the total number of outcomes here are going to be 5 plus 3 plus 1. So that's the total outcome. So 5 plus 3 plus 1, the total outcome is going to be 9. So that's going to be in my denominator. And then the probability that you have a red one is the desired outcome right here is 5 red. So you would have 5 ninths. So I would say fairly likely that you're going to get a red one. It's over half. And then the probability of not a yellow. So there are two ways I could do this. I could say 1 minus the probability of yellow, which would be 1/9. Okay, so this is the probability of yellow. Or you could count all the rest of them that aren't yellow, which would be 5 red and 3 green, which would be 8, out of the total outcomes, which is 9. So guess what? 1 minus 1/9 is 8 ninths. So it works the same both ways. And sometimes it's easier to count up the ones that are not yellow, but sometimes it's not. So you just kind of work that however you want to make that work. All right, so let's look at example two, typical probability problem here. You are going to roll a fair six-sided number cube, so a dice, one die, one of them. And then you're going to find the probabilities. What's the probability of rolling a five? Well, how many fives are there on a six-sided number cube? Well, there's one. And there are a total of six possible answers or six possible outcomes because 1 through 6. All right, so just 1/6 there. And then we had the probability of rolling a number greater than 3. So not including 3. So a number greater than 3 would be 4, 5, or 6. So that's going to be 3 out of the total pot outcomes, which is 6. So this would be 3/6, also reduced down to 1/2. So again, pretty likely something over 50%, I would say is pretty likely. The probability of rolling a 7. So, how many sevens are on a fair six-sided number cube? Oh yeah, there aren't any. So, this is an example of something absolutely cannot happen. So, you cannot roll 7. Okay. The probability of rolling an even number. So, how many even numbers are there? That's our desired outcome. Well, there's a 2, a 4, and a 6. So, there's 3 desired outcomes out of 6 total outcomes. Again, 3/6 reduces to 1/2. So, you always want to reduce that and get that in a better looking fraction. You can also write them as decimals and percents. Okay, there are 75 girls in athletics, and there are 28 volleyball players, 20 soccer players, 12 basketball players, and 15 softball players. So we are just assuming that those are just the single sport athletes because that's just for probability purposes. So we're going to find the probability. I'm going to randomly select a girl from athletics. And so now I'm going to find the probability that that randomly selected person is a soccer player. So how many soccer players are there? There are 12 soccer players. And then, oh, no, sorry, there are 20 soccer players divided by the total number of soccer players, which is 75. That's the total number of outcomes. Then I'm going to reduce that into 4/15. And then I'm going to find the probability that it's not a softball player. So a couple of things I can do there. I can add up everybody that's not a softball player. Or I can do this. I can do 75 over 75. Guess what that is? And then I'm going to subtract the number of softball players, which would be 15. So that's 60 over 75. So you could add up everybody with the softball players and put that in the top. But in this instance, I think it's a little bit easier to do it this way. And then this is going to reduce to 4/5. So I'll say it's pretty likely that you would not pick a softball player. So if it was something random like winning a prize, softball players probably wouldn't get picked. So I'm saying that wouldn't, but probably would. And then the probability of selecting a member from a basketball player. So that's going to be 12. This one's 12. So I'll have 12 over 75, which is going to reduce to 4/25. So a pretty small chance of selecting a basketball player and then not a volleyball player. So again, you can take 1 minus the number of volleyball players. So I'm going to say 75 over 75 minus 28 over 75 because remember when you add or subtract fractions, you have to have the same denominator. Now, if it were in decimal form or percent form, it would be a way easier to be able just to subtract 1 from that. And so therefore I get 47 over 75. And for once I cannot reduce. So if it's not a volleyball player, kind of likely, but I mean, it's over 50%, but almost. And then the last one, we are going to randomly select a number from the alphabet and see what these probabilities are. So remember that the alphabet has a total of 26 letters. So our total outcomes here are going to be 26. All right. So a letter after Q. So you could count up how many letters come after Q, and that is 9. So I have 9 out of 26. What about a vowel? Well, there are 5 vowels in the alphabet there, so we have 5 out of 26. Now let's talk about a consonant. So a consonant is going to not be a vowel. Well, so really this is anything this would say not a vowel. Basically, it's the same thing as a consonant. Now, what makes it nice is that I don't have to count these up because I can say 1 minus the probability of a vowel, which is 5 over 26. Or I could say, hey, there are 5 vowels. I know that 5 from 26 is going to be 21. So that's going to be 21 out of 26. So I would rewrite this piece as, instead of 1, 26 over 26 minus 5 would be 21 over 26. Again, the same process, but just a little bit different in that you take that 1 minus. So this is theoretical probability. So the difference in what we'll see is experimental probability is that the probabilities, the theoretical probabilities, is an exact formula, and it's not those probabilities are not ever going to change. When you look at experimental probability, those can change based on the experiment that's being performed. So remember that theoretical probability is the number of desired outcomes divided by the total number of outcomes. You can write it as a fraction, a decimal, and a percent. Here we just wrote it all with fractions, so it's just easier to see. Also, you can, if you're trying to find the probability of something that's not your desired outcome, you can do 1 minus that probability of the desired outcome and find that probability. And so now it is your turn to practice with theoretical probability with your skill check.